In this sequence of videos, we're going to discuss logarithmic functions. Let's briefly discuss the very basic ideas of logarithmic functions and why they might be useful to us. Let's suppose we have some exponential function f of t. So f of t is an exponential function. Now, because f of t is an exponential function, we can visualize the shape of its graph. Let's just for a moment assume that it's exponential growth. Then the shape of the graph will be something like this, and it may be steeper or shallower depending on the specifics of the particular exponential function, but the graph, its shape looks something like this. And if you notice, this graph passes the horizontal line test. That is, every single horizontal line that you draw intersects the graph at most once, which means it has an inverse function. We'll soon learn that that inverse function is the definition of a logarithmic function. So f inverse of t is a logarithmic function. So that is what a logarithmic function is. It comes from being the inverse of an exponential function. How about what it might be used for? In order to understand what it might be used for, remember that inverse functions switch inputs and outputs. So f of t, t being the input here, equals some output. Let's just say the output was 10,000. If this were true, then switching the inputs and the outputs, we would have that t equals f inverse of 10,000. And again, this is just using the definition of the inverse function and the fact that it switches inputs and outputs. You still might be asking yourself, why would this be useful? Well, what if we were in the real life scenario where f of t was the amount of money in an account at time t? Or perhaps worded a little differently, after t years. If that's the case, then saying f of t equals 10,000, in words that is saying, after some number of years, the amount of money in your bank account is $10,000. So amount of money equals 10,000. And maybe you don't know how long that money has to be in the bank account in order to reach $10,000. So for example, you invest $5,000 into a bank account. It has some interest rate. It's compounded a certain number of times per year. And you'd like to know, how long do I have to wait in order for that $5,000 to become $10,000? Initially, that might be a pretty challenging question. However, if you know the inverse function, f inverse, then you could simply put $10,000 into the inverse function, and what would be the output? Well, it would be the input that you need here. So there we have the basic idea, which is on this page, that the inverse of exponential functions are logarithmic functions, and an idea of why that might be useful using an example of compound interest and asking ourselves, after how much time do I have to wait after an investment in order to reach a certain amount of money?